Hi, and welcome to the fourth video in our PowerShell 7.2 for Beginners series. So in the last video, we took a look at array and array lists. Today, we're actually going to be finishing up the data structures and data collections in PowerShell with hash tables and custom objects. So we're going to start off with hash tables because that kind of leads us into the custom objects. So with the hash tables are very similar to dictionaries and other programming languages like Python. So they are key value pairs. So what that means is that there will be a unique key for every value in the hash table. So it makes lookups very easy in hash tables or dictionaries. You look up the key. If the key exists, you grab the value instead of like an index positioning system. So let's actually go ahead and let's take a look at how we can create hash tables and what are some of the abilities that we have in PowerShell with them. So let's first go ahead and let's create our hash table here. We're going to call mine my hash table, and we're going to make that equal to an @ symbol and then open and closing curly brackets. We're just going to hit enter once in here. So here we have an empty hash table. Now what we need to do is we need to put in key value pairs. So the way that we would actually put in a key is just by simply putting key 1 equals, let's make it equal to 100. And then we could put a space, and then we could put another key. Now the keys don't actually have the word key. You could actually put in, let's put in apple in here. And let's make that equal to 2.34. And you don't even have to have all the same types of values. You can have strings, integers, doubles, all mixed up in here. So let's actually put like name in here. And let's put that name as John Doe here. And let's put in another couple keys here. So let's put key 2. We're just going to put that as 2. We're going to put key 3, and we are going to store that as true. So here we have our hash table. It's just kind of a mess of different keys and different values, but that's all right. We don't really care what's in it. It could store anything we really want. So now let's actually go and see what PowerShell says is the actual type of this. So if we do a get type on the object here of my hash table, we actually have that it is an object and it is of type hash table. So that's very neat. PowerShell actually tells us that it is a hash table. Now with that actually comes some neat dot notations. So if we actually go ahead and we look at my hash table dot, we will actually see two things here that are kind of interesting, which is keys and values. So the dot keys will actually list off all the keys in that hash table. So if we actually just expand this out here a little bit, just scroll down just a little bit here. So here we have name, apple, key 3, key 2, key 1. Now, as you're going to notice, they aren't in the actual order that we put them in. And that is because hash tables aren't ordered, unlike array and array lists. Array and array lists have their dedicated order, which is why they are indexed. So if you go to index 0, it will always be that item, unless, of course, you remove it or you change it. But once you have something at index 0, if you display it, it will be the first item. The item at index 1 will always be displayed second. That's the way that it's going to work. Whereas hash tables are unordered. They can be in any type of order. Usually once you print out the keys, they'll always appear in that same order, but there's no way to actually ensure that they will be in the order that you want them to appear in. Now, the other thing that we noticed was the dot values. Now, this will actually print out all the different values. Now, as you're going to see, once again, they're not in the order that we put them in. Again, that's just because the hash tables are unordered data types. Now, the other thing that we can do, so we've seen how to see all the key values, and we've seen how to see all the values of the values. That's kind of a double kind of confusing there, but you can get all the values of your hash table and all the keys of your hash table as well. So then the other thing that we can do is we can actually get specific values of the keys. So to do that, there's actually two different ways that we can get the value from a key. Now, the first way, as we've probably seen it, is going to be a dot notation. So if we actually type in KE here, we will actually see that we do have key 1, key 2, and key 3. If we do a dot N, we will see that we have a dot name. And if we do dot apple, we have apple. So if I do dot apple here, we see that we get 2.4. If we do a dot key 2, we will see that I get 2, which is perfectly fine. Now, the other way that we can get values is actually the my hash table, open and close square bracket, and then in here we're going to put the value of the key inside of quotes. So if we want to get the value for apple here, we're going to put apple in quotes, and we get 2.34, which is exactly the value. And if we try to do, say, key 3, we get that same thing. Now, let's say if we put in a key that we actually don't have existing, we actually don't get anything back. We just get basically null back. Now, what we would typically say in this case is if we had the strict version set to on, we should get an error message. So if we do a set strict mode version latest, now as we've always seen in the past, if you had strict mode set to on, it would kind of help you, kind of tell you that there's nothing here and give you an error message. In the case of hash tables, this is not the case. Strict mode will not help you at all to determine if that key exists or not. So let me actually just turn this back off here. But PowerShell does give you a very handy method to check if a key exists or not. And that is actually if you do the my hash table dot contains key, and they also even have a contains value. So if you wanted to check if a specific value is in a hash table, you could actually do that as well. But let's first test out the contains key. And we're going to do the contains key on key 4, since that's the one that failed here. And if we actually run this here, we will see that we get false. It does not contain the key 4. But if we do a 3 here, we will see that it does give us true. So this is in a case, kind of what we've seen in the second video where we looked at the different variable types. This actually does give us back a Boolean. And then what we're going to see later on in the video series, we're going to see like conditional statements. So that would be like an if statement. We can actually check that if the key exists, then go pull the value or go remove the value. We're going to see how to remove them real soon. But basically just say, if this actually exists, then we can do something with it. And then if it doesn't exist, maybe tell the user that this record doesn't exist. So maybe you have to create it. Maybe you typed it in wrong, something along those lines. So we've seen how to do the contains key. Now let's actually go ahead and look at the contains value here. So for the contains value, let's actually go ahead and let's look for the value of true. And we get true. If we look for the value of 3, we actually get false because there is no 3. But if I look for the value of 2, we will see that we get true because it actually, key 2 actually does equal to 2. We do 2.34. We should get that to true as well. But if I do 2.35, we get false because it does not actually contain that. So depending on which way you're actually looking for items, you can find it by contains value or by contains key if you only know the key. In general, if you're using hash tables, you're probably going to be referencing the key more so than the value. because your keys are going to be unique. So if you try to put in two keys that are the exact same, we're going to see that we actually get a red squiggly line, and it says duplicate keys, keyfree are not allowed in hash literals. So in a hash table, you are not allowed to have duplicate keys. Keys are completely unique, whereas values don't have to be unique. You can have multiple things with the same value. If I do apple equals 2 and key 2 equals 2, there's no error. It actually lets it go through. So that is something to keep in mind if you're going to be doing lookups. The keys are definitely handy. So an example that you could use a hash table for would be if you have a bunch of records for users, you can actually store them in a hash table, have your object as the value. So you would have employee objects, which we're actually going to see how to create very soon. You would have that as your value. And then as your key, you would have the employee ID of that employee. You can easily look them up. But we're going to see how to create objects in just a few moments here. We're just going through a couple of the last items here for hash tables. So we've seen how to check for a key, check for a value. We've also seen how to look up specific values in hash tables. Now let's see how to add values and how to remove values. So there's actually quite a few ways that we can add values to a hash table. So the first way, which is probably going to be the most sensical way that we've seen in the past, it's going to be my hash table dot add. And then here it's actually looking for two parameters. So two parameters. Parameters are things that you pass in through methods. So each one of these is a parameter, and that gets passed into the add method. Now that might be a little bit confusing for now. Just be aware that it takes in two inputs here. We're going to be covering methods a little bit later on, but this is how you would use the add function. So what we're going to be adding is we're going to be adding a key 4, and we're going to be testing add function. We can actually space these out actually. So we're going to add key 4. And there we have it. So we've added it. So now if we actually look at the my hash table, and we just look at what it looks like now. Here is our key 4 testing add function. So that worked great. Now what we can also do is a my hash table. We can do the square notation here. And let's do key 5. Or key 5 equals added via square bracket. And we can also, before we check it out, we can do a my hash table dot key 6 equals added via dot notation. All right, so let's actually go ahead and let's run these two lines here. And if we look at the hash table, here we have key 5 added via square bracket and key 6 added via dot notation. So there are plenty of ways to add items to the hash table. And as you can even see, when we add things afterwards, they aren't even added at the end. They will be added in any order. Once again, just reinforcing that the hash tables are not ordered objects. So if you are looking for something ordered, definitely an array list is going to be the way that you would want to go. But if you're looking for key value, lookups, or anything like that, hash tables are definitely a very great tool, especially when it comes to looking stuff up. Hash tables are very, very great. All right, and you can actually even change values. So if we did a my hash table dot apple equals 0.5, and we set that up here, and we print out the my hash table, the apple is now equal to 0.5. So as you can see, you can do quite a lot with hash tables. You can easily change objects, easily add objects, and you can also easily remove objects. So let's say we wanted to remove the apple here. we would actually do a my hashtable dot remove. And once again, you just put the key in here. So we're going to put Apple. And if we run this here and we go to print out the hash table, we are going to see that we no longer see the Apple key here. We only get key 1, 3, 5, 6, name, 2, and 4. We do not have Apple anymore. If you try to run this again, once again, you do not get errors. If you were in strict mode, you would not get an error as well. It just tries to see if it can remove it, and if it can, it will. But again, you can always use the contains key to check for it. And then if it does exist, you could remove it. If it doesn't exist, you don't really have to do anything because you're going to be removing nothing. So that is something that you would be able to do. So that pretty much covers hash tables. I hope that that's pretty clear to you guys. If not, definitely feel free to ask me questions in the comment section or rewatch it. Sometimes hash tables and these more complex data structures are a little bit harder to understand. So I tried my best to kind of explain them with like real world examples, like that employee example for hash tables. Another one could be like an inventory system where the keys would be like product numbers or like barcode numbers. And then the value could be the price of the item, let's say. So let's say you had a store that sold like apples or bananas and tomatoes and all that other stuff. If you had a barcode or a product number for those items, or you can even look them up by name. I mean, keys can be strings as well, as we've seen. Then you would just be able to look up that item, look up Apple, get the price, and then charge them based on the amount that they bought. So an inventory system, an employee database, all can use hash tables. There's a plethora of different areas and scenarios that you would use a hash table. But also, what we're about to see is going to be very, very useful in all your PowerShell scripts that you make. We're going to be seeing how to create custom objects. Now, I'm also probably going to have a separate quick tip on custom objects, but this is really going to be the beginner on how to get started with these custom objects. So custom objects, as we've seen, objects in PowerShell are like hash tables, strings, integers. Those are all objects. We're going to be creating our own. Now, you might wonder, why do we need to really create our own? Well, we can actually create like employee objects, and we can store the employee ID, the employee name, their title, and all that other stuff, and then store that in a data structure like a hash table or an array list. And we can like reference them. We can compare their properties. They definitely come in handy, and they just kind of put data together that belong together. You can easily put that stuff together. So let's actually go ahead and let's show you guys 2 ways to create custom objects. So I'm going to start with the longer method first. The longer method is the method that you're going to see me use in quite a bit of the videos. This is just because I try to make it as clear for you guys as possible on how, like, the different steps that I'm going through. The second method that I'm showing you is just as good. It is like a short form to create custom objects. It's very great. I don't really use it in my videos, but I'm just giving you guys the 2 different options. All right, so let's actually go ahead and let's create our first custom object here. We're going to call this one employee1. And we're going to make that equal to a new dash object. So this is a commandlet that we're calling. So we're calling the new object commandlet. And we have to pass it a type name. And the type name that we're going to pass to it is PS custom object. All right. And then if we actually just run this line here and we try to look at employee1, we don't get a whole lot. We get equals, get hash code, get type, and toString. If we do the get type though, and we actually run this here, we will see that it is an object and it is a PS custom object. Now what we can do to this object is actually add a whole bunch of properties to it. So let's actually go ahead and let's take a look at that. So let's do a add member. So this is another commandlet that we're using. So we're adding a member and we need to put the input object to employee1. So what we're saying here is we're taking employee1 and we're adding a member to it. Now a member is going to be a property in our case. So what we're saying is the member type, we're going to say it is a note property. And the name for this property, we're going to say is going to be employee ID. And then you can also pass in a value here. So we're going to pass in the value of 1001. And let's actually create a few more properties here. So let's do add member, input object. We're going to put in that employee again. The member type is going to be note property. And the name, let's do first name. Now, typically for properties, compared to the camel casing, and actually my casing here is actually wrong, so it should just be employee one. Compared to the camel casing for variables, if you're doing like properties or methods, they should be just capitalized for the first. The first letter will always be capitalized, and then all the words afterwards should be capitalized as well. And for the value here, let's put in penny. And let's add one more member here. Input object and our employee object here. Just actually correct all of these here. It's not case sensitive, but I do like just having them all the same. It makes it easier for me to see where I'm using the object. So we're going to do a note property. We're going to do the name here, and we're going to say title. And we're going to put the value here as CEO. All right, so let's actually run all of this here. And if we actually go ahead and we print out our employee1, we will actually see that we get the employee ID is 1001, the first name is Penny, and the title is CEO. So this is actually perfect. Like we have all the data in here. You can actually even do a dot notation. We can actually see our properties here. So we have dot employee ID, kind of like what we've seen with array lists, hash tables, and arrays. Like we were able to do a dot notation, get like the count on it, get the length, get the contains key, contains value, remove, or the different keys. So when we do the dot employee ID, we get the employee ID back. If we do a dot first name, we actually get the first name back, which is Penny, which is awesome. Now, another thing that we've seen here is add member. Now, another option that we actually have is get member. So if we do a get member on, so here you actually have the input object. You don't have to put the input object. You could just put the object here. But if we do employee1, so if we do a get member on employee1, here we have all the different members for this object. So we have the get hash code, which is a method, get type, which is a method, the toString, which is a method, and then we have employee ID, which is a note property. It's a value. It's a string value. First name, note property, it's a string. It's a first name. And then title, it's also a string. If we actually did the employee ID just like that, we will actually see it is a little bit different. Here we have now the employee ID as an integer because we did not wrap it in quotes. So this would be completely up to how your system is really designed. Are you going to deal with the employee IDs as integers or as strings? Like to me, employee IDs are more, they're usually just numbers, but you're never going to have to do additions or subtractions to them. So I kind of put them in as strings all the time. But that is completely, that is a personal preference. You can definitely use integers for that. So that is how you would get a member. Now, a second way to create a custom object would actually be to put employee2. And we're going to actually make this equal to a square bracket, open and close square bracket. In here, we're going to do a PS custom object, and then an @ symbol, and then a curly bracket, an open and closing curly bracket. And then in here, we can actually put anything we want. So in here, we're actually putting our properties. So in here, we can actually hit enter, and we can put in employee ID equals 1001. And then we can do a first name equals Penny. Now you might be wondering, I thought that the @ symbol curly bracket was a hash table, and it is. And the way that this actually works is we're creating a hash table and then we're casting it to a PS custom object. So similarly to how I was explaining the array and array lists with the old method where I was casting the array list on an array, this is actually casting the PS custom object on the hash table. So it's converting that hash table into an object. So it's going to convert the keys into properties and the values into values for those properties. So it is kind of neat. It can maybe be a little confusing at first, but it is definitely a very shorthand of doing all of these steps. But if we do employee 2 here, and we just look at employee 2, we will see it looks exactly the same. And if we actually just change this here to Richard, and we just change this here to programmer, and we should have a different employee ID. So let's actually run this here. We will see that we get employee ID 1002, Richard, and programmer. And then if I run the employee 1, we get it's the employee ID is 1001, it's Penny, it's CEO. So as we can see, these two objects hold a lot of data, which could be great depending on the application that you're building. Especially in some of the projects that we've built on this channel already, like the Active Directory automation, we use a lot of objects in there. So definitely understanding how they work is very, very useful. Now you can actually make this line even smaller by putting it all onto one line. So if we did employee ID, and then after your 1002, you'll have to put a semicolon, and then you could put the first name, and then another semicolon here that separate all the different properties. Now you can use either way, it'll work. Now the only thing is that you kind of lose out at this point is maybe on readability. If you have a bunch of properties, that line will stretch really, really, really long, and people will have to scroll to the side to kind of read everything. But again, that is kind of a personal preference. I would always recommend to if you're going to use the second method, I always prefer it this way. It's a lot easier to read once you're going through someone else's code and they have something laid out like this. It's just easier on the eyes, easier to read. But that pretty much covers it for custom objects and hash tables. As you saw, custom objects are very similar to hash tables, and you can actually create a custom object from a hash table. So they are definitely very, very tied together. Now, in the next video, we will actually be looking at a very, very core PowerShell fundamental idea, which is the pipeline. So we're going to see how to connect two commandlets together and how to get them to interact with each other with the pipeline. So be sure to actually turn on the notifications to be notified when that video comes out, because that could be a very useful video. We're going to see that we could actually do some things a little bit shorter here with that pipeline, but we haven't seen it yet. So we're going to wait till that video and we're going to see what the pipeline is all about. As always, if you guys have any questions or comments, please let me know down below in the comment section. I will definitely try my best to answer every single one. If it's something specific, I'll just answer you directly. If it's something a little bit more general, I'll try to make a video on it. This way, a lot of people can benefit as well. As always, please hit that subscribe button, hit that like button as well, and hit that notification bell to be notified when that next video comes out. And I will see you guys on the next video.